Hello, I'm Clayton Owen, and I'm your instructor for CS 106. A lot of you have complained about this programming of Robbie the robot, and I wanted to take a little bit of time to try and show you a little bit about what this was about. So if you would, let's just look real quickly at the maze, and let's look at some of the instructions that you had. One of the first is that's basic rules. Robbie moves forward, and he goes forward 10 feet in 6 seconds. Now, if we look here, from A to B is 10 feet. So if Robbie's going to move from point A to point B, it's going to take him 6 seconds. From B to C, now remember, Robbie's moving in a northward direction. After he hits point B, in order to move from B to C, which is 35 feet, he's going to have to, number one, turn. Now, you have to make the decision. Do I have him turn just 90 degrees and then move backwards? Or do I have him move more than that, 240 degrees, so that he's facing this direction, and then he can move 10 feet at a time? If you have him going backwards, he can only move 5 feet at a time. And if he can only move 5 feet at a time, it takes 4 seconds. If you're going to have him turn, every time he turns, it takes 2 seconds. So in other words, if he just turned once here and then backed up, it would cost him 2 seconds, and then he's going to have to go 35 feet, which would mean 7 times 5 is 35, and it would take him 4 seconds for each one of those. So 4 times 7 is what it would amount to. So each one of those, if he's moving backwards. On the other hand, if he turns completely around here, that's a 1 turn, 2 turns, 3 turns. That's going to cost you 6 seconds in turn. So it's 2, 2, 2. He's turning 2 times, actually 3 times he's turning. Then he can go forward, and in this case, he could go 10, 10, 10. That would get him within 30 feet, at which point he's going to have to turn around and do the last part. So obviously it would make better sense for Robbie to turn around once, go 5 feet, then completely turn him around again and have him do the rest in 10-foot segments to where he lands here. So just remember, for him to move this direction, he's got to be going 10 feet, and he does it in one move. Here you have to decide, do I turn him completely around? Do I just turn him backwards? How far can he go? But remember, he cannot go, if you have him facing forward, he can't go 10, 10, 10, and 10, because this is only 35 feet long. So you have to consider that. And then you have to consider your turn, and your turn, and your turn. So a lot of it is just simply doing it on pencil and paper, trying to figure out the way that is the quickest for Robbie. Then when you mark each one of these steps, and remember, you don't add them up, you mark each step, then you just simply put it on a spreadsheet. You break your spreadsheet down, and you talk about how many seconds it took for him to move from point A to B, C, and D, and so on. And then you simply add that part up, and you're done. Hopefully this has clarified it a little bit. As you can see, it's not that hard, but it does take some thought, and it is a problem-solving assignment. So, and let's face it, you are in college, and